Today, we're going to talk about a single moment in time that might have just completely changed the future of science. A moment when an AI didn't just find an answer, it created something totally, fundamentally new.
OpenAI's president, Greg Brockman, used just 3 words to describe what he witnessed: a sign of life. Now, in the world of artificial intelligence, that is a very loaded phrase. So what on earth was he talking about?
And that's the big question, right? We're not talking about whether an AI can solve a math problem that, we already have the answer to in a textbook somewhere. We're asking, can it go into the complete unknown and come back with brand new knowledge? Okay, so let's set the scene. The date is August 20th, 2025. An OpenAI researcher, Sebastian Bubeck, decides to run a little experiment. He takes a brand new math paper, one with what's called an open problem, which is really just a fancy way of saying nobody on Earth knows how to solve this yet, and he just feeds it to GPT-5. Now, before we get to what the AI did, we've got to understand the problem it was looking at. And don't worry, you don't need a PhD for this. We're going to break it all down with a super simple idea: a bowl and a ball.
So the paper was all about this field called convex optimization. It sounds super technical, I know, but the core idea is actually really easy to picture. Imagine you've got a perfectly smooth, simple bowl. Convex optimization is just the math for finding the one single lowest point in that bowl.
That's really it. It's like letting a ball roll downhill until it finally settles at the very bottom. But here's the crucial part. This isn't just some abstract math puzzle. This whole ball in a bowl idea, technically called gradient descent, is the fundamental way that pretty much every modern AI learns. It's how they roll their way toward a better and better answer. So why does the shape of that bowl matter so much? Well, if the path to the answer is a nice, smooth, predictable curve, that's great. The ball rolls right to the bottom. But what if the path is bumpy? What if it has flat spots or little dips? That's a huge problem. An AI could get stuck on one of those flat parts, and you'd think it was done learning, when really it's just stuck. So the researchers wanted to know, how can we guarantee the path is always a nice, smooth curve?
And this is exactly where the human researchers, they hit a wall. They'd figured out part of the puzzle, but a really critical piece was just missing.
Okay, check this out. The researchers Barzilai and Shamir were looking at something called step size. You can think of it as how big of a nudge you give the ball each time it rolls down the hill. They proved that if your nudge was small enough, below a certain value they called 1/L, you were guaranteed a smooth ride to the bottom. They also proved that if your nudge was too big, over 1.75/L, the path could get bumpy and unreliable. But what about in between? That whole zone was a complete mystery, a massive question mark in their math. And this was the open problem. That range between 1/L and 1.75/L, it was completely uncharted territory. They had a hunch you could probably take bigger steps and still be safe, but they had absolutely no way to prove it. The math simply wasn't there. So that's the exact problem that Sebastian Bubeck handed over to GPT-5. He basically pointed the AI at this giant gap in human knowledge and said, go figure it out. What happened next is just wild. In 17.5 minutes, GPT-5 came back with an answer. Think about that. A problem that had stumped brilliant human minds, solved in less time than it takes to watch a sitcom. And it didn't just give a hint, it returned a formal, structured mathematical proof that was totally new. And let me be absolutely crystal clear on this. This was not the AI just finding a pattern or spitting out something it had read before. The solution it came up with used really advanced math concepts, things the human researchers hadn't even thought to apply here. It extended that safe zone all the way from 1/L up to 1.5/L. This knowledge did not exist anywhere in its training data. It wasn't on the internet, it wasn't in a textbook. GPT-5 times reasoned its way to a brand new piece of mathematics. But hold on, because the story doesn't end there. In fact, what happened next is, it's arguably just as incredible as what the AI did. So let's just walk through this discovery. First, you have the humans, who prove the concept works up to a point, and then they get stuck. Then the AI comes in, uses this totally original approach, and pushes the boundary way further. But here's the kicker. The original human authors saw the technique the AI used, and they had their own aha moment. They took the AI's core insight, built on it, and solved the entire problem, pushing the proof all the way to its absolute theoretical limit. And this right here is the real takeaway. The AI wasn't a replacement for the humans, it was a catalyst. It was the spark. It provided that missing piece of the puzzle that let the human experts see the whole picture and make an even bigger leap forward. So, as you can probably guess, this whole event kicked off a massive debate. People started asking, what does this actually mean for the future of, well, for the future of everything? And really, two main camps formed. On one side, you have people saying, this is it. This is evidence of real creative reasoning. We are getting so much closer to AGI. This is the sign of life camp. On the other side, you have more cautious folks who say, okay, whoa, let's slow down. It's an incredible milestone for sure, but it's a very, very specific result in one narrow field of math. A huge step, they'd say, but not a revolution across all of science, at least not yet. But no matter which side you're on, the implication here is just staggering. We're talking about a potential massive acceleration of science itself. Just imagine AI systems that can scan all of human knowledge, find the gaps, and then come up with new ideas to fill them. This isn't about replacing scientists. It's about a whole new way of doing science. Human creativity and intuition, amplified by an AI that can see connections we can't. So I guess that's the real question this leaves us with, isn't it? It's not a matter of if AI will contribute new knowledge anymore. It's a matter of how and how fast. What happens to human progress when our smartest partner in the lab isn't another person, but a machine that's capable of truly original thought? We don't know the answer, but one thing seems pretty clear. We just took a giant step into finding out.